Hey guys, welcome back to the 1936 RCA RR-359 field test set television restoration project, but it's a mouthful. Alright, it's been a few weeks since the last update and I want to get you up to speed on things. I've spent most of my effort over the past few weeks doing more research and tracking down more replacement parts. Spent a bunch of time and a bunch of money, and I've yet to pick up a soldering iron. And I want to show you why and what exactly has been going on. As I mentioned in an earlier video, I'm going to be starting with the power supply, which is a good place to start on any vintage radio television project. This is the power supply. It is large and very, very heavy. Now, I've been tracking down parts for this, and while I'm waiting for them, I wanted to get it off the workbench. I've gone back and forth with this a few times. It's 100 plus pounds. It's not easy to move around. Even with the turntable it's currently on, it's still awkward. So, for the foreseeable future, it's going to sit here on the floor in a safe spot away from everything else. What I have been doing with this is cleaning. I've been using CLR and scouring pad, but not steel wool. This is just sort of like coarse plastic weave, so I don't want to scratch things up, and done a pretty good job so far. Still have a bit more to do. So when I got it, it kind of looked like this everywhere, and in some places some tar had leaked out, especially where the original high voltage transformer had some kind of catastrophic failure. Still see there's some tar goo here and over here, so that I've been dissolving with acetone, and then again the CLR to clean it. Also a bit of corrosion, the really light surface corrosion of CLR is alright, but here and there I've needed to use some naval jelly. Identify parts a bit here. I went over this in the last video, but I want to briefly go over it again. So power transformer, filter chokes, more filter chokes, high voltage transformer for the focus, I believe, and some capacitors, and the box to shield the two rectifier tubes inside. Now, the original high voltage transformer was here. It died, I presume. They put in one that looked like from a TRK-12 set, but that was also bad, so I just took the thing off, and I've cleaned up most of the tar that it used out. And at the end of the last video, I discovered that a Radiola Model 80 main power transformer has a box that's exactly right for this one. So I scavenged it off that chassis. Since the last video, I got the insides out and cleaned off all the paint and cleaned off the corrosion. So now it matches the other boxes pretty darn well. Now to get it out, the power transformers in here, they're potted with tar. I ended up using both heat and cold. I initially wanted to get the thing out, and it was really potted in there with a lot of tar. So I threw it in the oven when nobody else was home. It did make a little bit of an odor, but I didn't get it super hot. I just went overall, get it to about 275 or so, which kind of softened it. Then took it out and used a heat gun to keep it warm, and got some vice grips on the transformer inside. After I chipped a little bit of it away, I was able to get a hold of the core of the transformer. It was rock it back and forth while heating with the heat gun, and eventually pulled it out. Then I popped it in the freezer and was able to chip out most of the remaining residue inside. And then I just filled it up with acetone or lacquer thinner and melted out the insides. And the acetone also dissolved the paint pretty darn well, and it was just painted brown. Alright, so that's that, and that will go right there. Alright, now, there's a challenge of, yeah, we got an empty box, we got to put something in it to replace the functionality of that. Another issue I've got on this chassis and some on the upper chassis is busted tube sockets. So this is for one of the rectifier tubes. Broke away the phenolic sockets they use throughout this set. The components down below that grab onto the pin are very robust. They really tightly grip the pin, but the insulating material is phenolic, and a combination of very stout metal connectors on brittle phenolic, that does not, they break. from the tubes getting repeatedly replaced. So, got to replace them with something. And some other places, things have been modified or more broken sockets. So I need some 4-pin, some 5-pin, some 6-pin, some 7-pin. Surprisingly hard to find good ones, good quality that will fit in this right. There are modern ones made. Mostly they seem to be out of China, and they're white ceramic, gold-plated for the tube amp people. They would not at all look right in this set. I can get some flimsy ones, things I've scavenged out of radios and that, but they either don't fit right or they're not really any more robust than these were. So I'm still searching, but I did pick up 2 of these guys, which are really nice quality amphenol-phenolic, high quality sockets, but not quite the same as the originals. And you're going to be hearing me say this a lot. I'll do what I can. I'm going to try to not make anything that's irreversible, but I want to make this thing work. And, you know, maybe eventually I will find perfect, exact, identical sockets as these 2. I can replace them, but I don't have them now, and I haven't found them yet. But I'll keep looking. Meanwhile, I'll try to use these. Now, the problem with these is I got these larger ears out here for mounting. They're spaced a bit further apart than these 2 riveted things here. So to get this out, I have to drill out these rivets, unmount it, and I can pop this in. I can use a file to enlarge those slots so they're closer to this, so I can get those to line up with those original holes. But there's another issue I've had with a few things in this set, is that even if this did mount perfectly, the holes are different. On this, so there's 4 holes and they're not identical. These 2 are larger. They're for the filament pins. And in this case, they're next to the rivet. In this socket, the 2 larger ones are on this side. So even if this dropped in and fit perfectly, we go from the 2 larger holes being here to the 2 larger holes being there. Thinking, oh, we can rotate that. Not really. There are molded notches in this. And maybe. I'll see. If I get this retaining ring off, can I rotate this 90 degrees? Possibly. Possibly. But I got some other cases where that's not going to be possible. So, and then I don't think this opening is quite the same as that. And this steel's really thick. So the sockets look like they're kind of down in there far. It's because this is really heavy steel on this chassis. And this has a chamfered edge there. And this does not quite fit into those holes. But I can put a little spacer on this or something. In other words, I can make it work, but no, they are not the same as the original. So be it. Here's a peek underneath at those sockets. And see how the structure is there, where it's sort of an outer and an inner metal structure that really grabs those pins tight. Here is that modern amphenol, or newer amphenol one. Not quite the same. And here are some ones I've scavenged out of old radios, and this is what you typically find, where it's just sort of a formed metal collar. Not at all like that. Now let's switch back to the workbench and show you some of the other stuff I've picked up. Here's a schematic, and this is what we need to replace. High voltage transformer, which is not just the high voltage transformer, it also has 2 filament windings, one for each of the high voltage rectifiers. There's a bigger one for the main high voltages, a smaller one for the focus voltage. I consulted with some other restorers and was informed that, hey, a really nice source of high voltage transformers is neon sign transformers. So I picked one up. Now the original, or the goal is to get about 6,000 volts DC. This uses a single diode rectifier, so it'd be a half-wave rectifier circuit with filter choke and some filter caps. So I went with a 5,000 volt 8 milliamp transformer for a few reasons. One, it's readily available. Two, it will fit inside of that shell like so. the load at the final output, we have a fixed load of 1 milliamp. It's 6,000 volts DC, and there's a 6 mega ohm resistor on it. We'll draw 1 milliamp. The CRT, say it's completely cut off. There's no image, like a completely dark screen, be 0. If it's solid white, probably be about half a milliamp. So our total load's going to vary between 1 milliamp and 1.5 milliamps. Now, there's a peculiar feature of these transformers. There's a slot in the core down in there. You can get the angle right, you can kind of see daylight through it. That's intentional. When these have very little load or no load, the output voltage is higher than when it's under load. And that's because these are meant for neon signs, and to get the gas to ionize and to strike to start glowing, it needs a little bit of a higher voltage than the steady state voltage once it's been ionized and is glowing. I've heard from another restorer that might be a problem with this. It kind of depends where the load is. So this is rated for 8 milliamps. We're not going to be drawing anywhere near 8 milliamps. So as it varies between 1 milliamp and 1.5 milliamps, how much is that output voltage really going to vary? And do we care? If it's only a couple percent, we would never notice. If it's like 50%, yeah, we would notice. So, with that in mind, and that we work out the filament transformers, I want to breadboard all this as close to the final thing as possible before I commit anything to the chassis. Because I need to fit this inside here. And for the filament transformers, one tube needs 5 amps at 2.5 volts. I picked up this guy. Yeah, it's overkill, but these are available. I got one on eBay. I got one from Surplus Sales in Nebraska. It's not cheap, but they're new old stock, super nice transformers. This is 10 amps. I only need 5, but it's 10. And it's rated for 10,000 volts. Because these have directly heated cathodes. They're not indirectly heated, so the filament will have a very high potential on it, so you need to have a heavily insulated filament transformer. So that takes care of 2 of them, but that just about fills the box. We need a 3rd one. My original hope was to use 2 of these guys, 2 of these and 1 of these. Now the other rectifier needs 1.5 amps, so it could be a much smaller one. And I can potentially get a smaller one, the 5,000 volt, like 2 amp or something like that. The Triad makes them, I think. I might do that. Because 2 of these won't fit. It looks like they'll fit, right? But not quite. If I put 2 of them next to each other, it won't quite. And I'll play around with it. I'll pull all 3 of them out, but I'm pretty sure it won't fit. But now, the restorer who used one of these had an interesting suggestion. Notice there's some daylight around this primary winding. We can take some wire and wrap it around there, just like they do with a modern flyback. So, like this guy right here. So there's a loop or 2 of wire around the core. This is the filament power for the high voltage rectifier tube. They steal it from the high voltage output transformer. Possibly we can do the same. Now, the thing is, that transformer runs at almost 16 kilohertz. This is a 60 hertz transformer. If I just throw 1 loop around there, will that be enough? Maybe 2 loops. That's what I want to experiment with. Because if we can do that, it'll save us having to get another transformer. This is what I'm talking about. Wrapping a couple, 1, 2, 3 turns. Maybe we could get 4 if we need it. Around there, steal some power from this core. So 1, will that sufficiently power that tube? 2, will it affect the operation of this? 3 is the output load varies for the high voltage with that gap in the core. Will that be a problem? Now what another guy did, he filled in that gap. He took this thing apart and I forget what exactly he did. He cut them or some way to minimize or eliminate that gap. I'm hoping to avoid having to do that. Alright, let's move on to the bleeder resistors. So 6 1 meg resistors and then a couple others for the focus circuit. The board they were mounted on was cracked. I want to replace it, of course. I'm going to try to use this. It's something called Norplex. It's basically phenolic board material, same thickness as the old stuff. Need to cut it down a bit to the exact width and length. And I think I can transfer over the terminals. They originally mounted, they drilled a hole through this material, they put the terminal through, and they flanged over the end. If I break this board apart, I can get them out. I can try to straighten those bent over bits of metal and put it through a new hole and bend them over again if they break off. Well, I can probably thread a screw down in there or epoxy them. I'll figure something out. If I have to, I'll use different terminals. Alright, but what about these? Well, I picked out some nice new resistors made by Yageo. They're 1 meg, 2 watt. I think these are rated for 7,000 volts. These are high voltage rated power resistors. So we're going to use these. So I could just put these in the terminal and say, hey, who's going to see this under the chassis, right? Well, no. We're going to replicate some dog bones. In the past, I made molds, and I used 2-part epoxy putty and actually like molded it over the resistor and then painted it afterwards. But I want to do something different this time around. We're going to use a technique. I found a nice video on YouTube, short and sweet. I'll include a link in the description on using, well, tubes. In particular, these. These are fiberglass tubes. Go by a few different names. I have one on here. Something called GRX, FR4, Garolite. Yeah, this is Garolite. Halogen-free. Got a few different sizes. Now this is getting expensive. I'll tell you why. One, I wanted to get these from, I think, Tap Plastic. There's a common, or T-Plast, something like that. There's a plastic supplier that caters to both, I think, industrial and hobbyist stuff. But they were out of the sizes I needed, and they don't have the smaller size at all. So I went looking around, and eventually I found McMaster Carr has them. So I got a larger size for the 2 watters, medium size for the 1 watters, and the smallest for the half watters. And this was the one that was hardest to find and most expensive. I will also warn you, these come in a big shipping tube, and because it's longer than a certain, like 3 feet or something, you pay a premium. I think I paid $45 to ship these tubes. And the tubes themselves aren't particularly cheap, so yeah. So there's that. So what do? Well, you select your size of choice. Probably go with the largest size for these. Now, neither of these is exactly what these are. The medium is a little bit smaller, the larger is a little bit larger, but either one is pretty darn close. So what you do is you cut a piece to the length, and then you drill a small hole near either end, and you put your new resistor inside, and you take some bus wire and feed it through those holes you drilled in the tube, and you wrap them around once, and then you solder them to the resistor inside, and that simulates these outer wires on here, and then you leave, of course, a length to, mount wherever it needs to. Then you got to fill up the tube with something, and then we'll paint them. Well, what are you going to fill it up with? Well, these resistors are going to dissipate a watt. 1,000 volts across a 1 meg resistor generates 1 watt. These are not all that heat conductive, and if you just put it in there and like filled it with hot glue or something, the resistor would not breathe all that well. So what I'd like to use is something that's electrically insulating but thermally conductive. So I went a bit overboard because I wanted to experiment and give you guys some options. So I picked up some of this stuff. Basically, it's potting compound. So it will transmit heat, but it has good electrical insulating properties. And then this stuff, which is even more expensive. Between these two, we're looking at close to $200. So not for the faint of heart, but this is kind of a chance of a lifetime set, and I want to share the experience with you guys. So I wanted to get some top-notch materials and show you what is possible. So put the resistor in, drill the holes, put the resistor in, feed in bus wire, solder it up, fill it up, and then we paint them. And to paint them, this was easy enough. I went over to Michael's or Joann Fabrics or something like that, and I found, hey, this assortment has all the colors you need for resistors. For following the color code there, so we can paint them up with that. And then if we want to do one, some of these are, I don't think any on here, but if they're 20%, rather there's no tolerance band, but if they're 10%, there should be a silver band on them. So if I need that, I got some metallic silver too. So we'll have some fun with that. However, I'll save that for later. Let's get it to work first, so I can just tack these guys into the terminals, and you can experiment with that. But that's the end goal, is to use these Garolite FR4 type tubes and this thermally conductive epoxy and paint and make some dogbone resistors. Now, I also anticipate there'll be other resistors on the main chassis of all different wattages that may need to be replaced. That's why I got a lot of supplies. It's not just this board that needs to get replaced, I anticipate. All right, let's move on to capacitors. Now, when I talked about this chassis initially, I pointed out that a couple of the electrolytics have been replaced. These two guys are not original. These two are. One way to tell is just the wiring was undisturbed and they look like originals, and they have RCA part numbers, but they have two distinctive dots on top. Well, I asked around online, put an ad in the Antique Radio Forum Classifieds, and somebody had a couple identical 68 597-3s came out of an RCA radio from the same era, and he wanted a very reasonable amount of money for them and shipped them. Fortunately, they got knocked around the world a couple times in shipping, so I was on pins and needles for a few weeks, but they did eventually show up, and they are perfect, exactly what I needed. So we now have a match set of 4 identical caps for the power supply. Isn't that pretty? So what am I going to do? What am I going to do with them? So I could just mount them and mount new caps down below, but just in the same spirit as the resistors, let's see if we can restuff them and hide all the modern parts. So I'd shown that I picked up some of these guys with the thought that I could use them. Now, if I was just going to use one of these, and it was this guy, I'm pretty sure this will fit in here. Even using calipers and whatnot, that it will. But here's the thing. Well, okay, let me just take a step back. I could use electrolytic caps. They're tiny. 3 of these are 18 microfarads. One of them is 10 microfarads. So we're talking just itty bitty caps. But when you first turn the set on, there's no load. The highest potential output that hits the 10 microfarad, it's pretty high voltage. So if you look at this is a 600 volt cap. So I got to thinking, well, why don't I get something really robust? So these are 10 microfarad, 600 volt polypropylene capacitors. These will outlive me, they'll outlive you. But these are 18s, not 10s. One of them's a 10. The other 2 are 18. Well, if I got 18s, they're much larger in diameter. There's no way they would fit. So I was thinking, well, I'll use 2 of them, right? Put them in parallel. Make a 20 microfarad, 600 volt cap. And lengthwise, would they fit? Sort of, kind of, maybe. But the diameter is slightly too big, too. It really gets, like I said, it's maddening trying to track down parts for this, because everything is close but not quite right. So it's a little bit too long, a little bit too large in diameter. I looked through a whole bunch of different makers of these. I couldn't find anything that was, all the boutique stuff, all the audiophile sites. Nothing's going to quite fit in those. And then I got to thinking, well, what else is there? Well, because I also need to rebuild a box capacitor. Let's find around here somewhere. This guy, which also has, well, it's right here on the side. It's got 2 10 microfarads and a 50 microfarad. Well, they also sell these polypropylene caps in box form, so I got some of these boxy types to fit in here. Now, what I hadn't thought about is, well, hey, can we put a box inside of a circle? we put a rectangular cap inside of a cylinder? And I believe we can. Maybe not these, but I'm hunting around on DigiKey, found these guys. Got a bunch of them, got 10 of them, so I got the volume discount. And these are 10 microfarad 600 volt caps. So these are equivalent. Quite a size difference, huh? And notice, if you go this way, hey, the diameter of this is larger than the height of this. So this should fit in there. Probably. What I don't know is how thick is the aluminum wall on this, but I think they will. And again, I'll have to put two in parallel. I'll have to bend these leads over, insulate them a bit. But I think I can get, and lengthwise, I can fit 3 of these in here probably. I think these will fit in here. That's the plan. Okay, so how do you get these open? Well, you can take a hacksaw and just cut them in half, right? Just shove the new caps in there. Yeah, but then of course you'd have a seam. And these mount flush with a big nut on the bottom. So there's no collar, there's no mounting or anything here. I've worked on some where there's a mounting collar and you can just cut it here. When you put it back, that collar holds the seam. But what do we have up here? We have a seam. That's how they make these in the first place. This is all molded as one piece. But the top is a separate piece that's press fit in. You cut it here. And then you take this off like a bottle cap, put your new caps and clean out the insides. By the way, these weigh almost nothing. These were wet originally. There was a fluid in here. Those fluid's long gone. There'll just be some aluminum mesh in here. An anode lead going up the middle. It's easy to clean out from the top side. Like basically this rod goes all the way up inside. We'll just pull the whole thing out. And that's what those vent holes are about. So if these overheat, the gas vents out the top. But anyways, we can cut them here, put the new caps in, and on this top cap we'll have a disc. We can glue a cork or a rubber stopper to the bottom of that and just pop the guy right back down. If you ever need to service it, we can open it up, pop it back down. Before I do that, though, I will experiment on one of these guys. I'll do this guy, I think, and show you the technique. I might have showed it years and years ago. I haven't done too many radios in a long time, but I've definitely used this technique before. I know it'll work. Just a question of how well will these fit inside. All right, so those are the main filter caps. That's the plan for those. Let's talk about tube sockets again for a bit. There's some others I picked up. So yeah, they're phenolic like the originals, but you can see the part that bites onto the tube pins is nowhere near as robust. But, so what else am I missing? I'm missing the tuner, I'm missing the vertical oscillator. The vertical oscillator uses a 7-pin tube, a 6A6, which would fit into one of these. I also want to breadboard that up on the workbench. I picked up a couple vertical blocking oscillator transformers, just like the original used. Well, I mean, electrically equivalent. So I want to breadboard this up as well. Get a 6A6 tube, use one of these sockets, use one of these transformers, a few discrete components, and we should be able to build an oscillator and totally test it out and get it working up on the workbench. And likewise, a tuner which uses a 5-pin tube base. So with that in mind, I picked up a couple of these guys, but I'm not so sure they're going to work out. These circuit boards. Is what I was thinking. I got inspired by these guys. I was at an auction and I bought a tube caddy and it had a whole bunch of these inside. They were from an electronics training course back in the day, and there's little faint stock clips here going to every pin on the tube, so you put your tube in there and you could prototype breadboard your circuit, put your components or wires in there. That's kind of what you could do with this, but you're missing some stuff. You don't have the clips, you don't have the socket. And I can't quite figure out what kind of socket you're supposed to put in that. So if I take this and go over to that, the holes don't line, well, they kind of line up, but these lugs, I mean, they don't, like, how do you, and then it's missing all the clips that are on the outside. What I think I'll try doing is taking some heavy bus wire and put like a 1/2-inch length on each one of these and then feed it into this board so it'll kind of sit like that. Then I can attach my components to it. Something like that. The idea is to get something kind of like this, but for a 5-pin tube and a 7-pin tube, so we can prototype the vertical oscillator and the tuner using these guys. And I recently got a nice 0 to 350 volts or so, 400 milliamp power supply working, and I've got a dual power supply up here on a workbench. Between those two, I should be able to do the filament supply, the negative grid bias, and the plate supply, no problem. And these are both just one-tube circuits. It's one tube circuit for the vertical oscillator, one tube circuit for the local oscillator for the tuner. So I think we're going to have some fun with that. So that's the plan. Keep cleaning up the power supply chassis. Experiment with somehow rigging up the high voltage supply and simulating a varying load and see what kind of output voltage do we get. And then experiment with the vertical oscillator, local oscillator, and eventually fabricating replica dog bones and restuffing these caps. But I'll save that for later because we can get the whole set working by tacking in the caps and tacking in the resistors. We don't have to have restuffed parts to get this thing working. But there you have it. It's not going to be a cheap project. It's not going to be a fast project. But I knew that going in. That's it for now. Thanks for watching.